Hello, welcome to another video. Today I'm doing accounts merge, lead code medium. Given a list of accounts where each element account is a list of strings where the first element accounts at index 0 is a name and the rest of the elements are emails. 0th element is name and rest of the elements are emails. Now we would like to merge these accounts. The accounts definitely belong to the same person if there is some common email to both accounts. Note that even if two accounts have the same name, they may belong to a different person, as people could have same names. A person can have any number of accounts initially, but all of their accounts definitely have the a person can have any number of accounts initially, but all of their accounts definitely have the same name. After merging the accounts, return the accounts in the following format. The first element of each account is the name, and rest of the elements are emails in sorted order. Okay, so John is the name, and all these email accounts belong to John. There is another John, but as they said, even if two accounts have same name, they may belong to different person, and as people can have same names. So this John might be a different John. John Smith, but his email is same. So these two Johns are really the one person, and all these accounts belong to this one person, right? Mary has only one account, John again, Johnny Bravo, but this is a different John. Okay, so output is John and all his accounts, and Mary and John. Okay, so we have three in the input, we have 4 names. In the output, we have 3 names. The first and second Johns are the same people, same person, and the common name. Okay, so this is a graph problem. We can think of these emails as nodes in a graph. John New York, and John so this, yeah, and this. So yeah, we can think of these emails as nodes. Connected graph. What is it called? Cluster. A group of like when emails are connected to each other by an edge between them. Okay, so Mary's mail, we can imagine as a node without any connection to other nodes in the graph. It's a single node. I know there is a term for these nodes. I don't know graph theory. And Johnny Bravo also being the only node, not connected to other nodes. The ones which are connected, they belong to the same person. So the idea is to create an adjacency list to represent to represent this relation, and then run a depth first search on that adjacency list to find out what account belongs to who. This is a very lengthy version, I remember. Okay, so list. This is our final list of result new array list. In order to create a list, we need a hash map. And since it's a graph question, we also need to keep track of the nodes we have visited, so we don't get stuck in a cycle loop. Map. It's a map of string and list of string. So this string is a node, and this list of string represents the node, other nodes that with which this node is connected. A map, new hash map. Right. So we're gonna say for each account, for each account in accounts, get us the first email, first email, account dot get, because it's a list, account dot get element at index 1, because at 0th index it's name. We don't want name, we are creating a, I should call it agents. I don't know, I have always have a hard time pronouncing it. ADJ, I'm gonna call it ADJ. Yes. And so I'll put this first email in ADJ. If our list contain, if it doesn't contain or contains key first email, then we simply add it. Dot put first email along with, and we map it to a empty array list, which will eventually contain the nodes or other emails that this email is connected to, which overall represent all the emails. It's a group of emails that belong to one person. ADJ. And yeah, so now we need another loop for well, let's see. This is a map. This is something I wanted to do. Smith and the list of the nodes and for oh, for mm, mm, John Smith, John New York, and there is another. So John Smith, John New York, and John New York will also be present as a key and will have its own list, and John Smith would be part of that list. Now we just need to grab the other this first node and then add this to our node. Yeah, the loop for I is 2, I smaller than account dot size. We're talking about this sublist size I plus plus if string other account is account dot get I. if let's see is not if not present as a key, other account, if they are not present as key in the map, then we put them in the map. adj dot put other account new array list, and we also adj dot get first email dot add other account adj dot get other account dot add first email. All right, I just want to make sure that the map is created the way I want. adj print return result. John Bravo mail. Okay, so this is empty. All right, John Smith, John New York, John 00, John 00 should have John Smith and John New York. John New York should have John Smith and well, John New York should also have no John New York, John Smith, John Smith, John New York, John 00, John 00, John Smith. Okay. It's time for dev first search. We also want a result in sorted manner. I need to create a helper function. Private void dfs or boolean. Boolean need a set of hash set string visited new hash set. String account or mail. What is it? AJ hash map or map only. string and list of string. PTG, super good. And what we want to do in the search, that we want to check for each element. This male is our key for our hash map. So we're going to check for string name or account at get mail. We'll check. Check. For string account in account string name of the person, get name at index 0, and string name at account get 1. List this one. Detail list detail dot add name and we will also pass in this detail function in our def search. I'll pass in this mail and adjacency list, and then what else we need here? We also need a visitor. So there is a list detail 1D list and a hash set. So Hang on. Um, you can check if the mail, if set contains, if the mails has already been visited, if set contains mail, or if it doesn't contain mail, only then do the reference search. Add this name, the detail, and run a reference search. Okay. And I think we need to define this inside the loop. Well, okay, the job of this function is to fill this detail list, which and it will do this by checking through this adjacency list, checking nodes, and then just following the link, right? Following the okay, it will check something like, okay, I'm at John Smith, or what does this node connected to, or where does this go? It will jump here, John, New York. That means that these two um, mails belong to the same person, and then it will come here because we are using this we are using this mail as a key. It will come here and see this John Smith, and since it has seen this already, it's just seen this before, so it knows they belong to the same person. Hang on, I still have doubts. Let's see, account J detail and our set of string. As soon as any mail enters this function, we will add it to our visitor. Set.add mail, and of course in the detail we'll do the sorting work at the end. Add mail. All right, well, okay, if this visited contains, the visitor does not contain mail, then find its neighbors. Void. Okay, and last one was Z. This should populate our list. Mm, mm. Result dot add name list detail. Just want to confirm we are on the right track. Expected. What? This it. Visited. Well, John Smith. Why is there an empty list here? Not expected at all. There is an empty list because we are adding it outside of if condition. Okay. Doesn't exactly do the diff for search. Is a system dot out dot print edg map. All right. Let's just sick real quick. Mary announcement John 00. John New York should also have this John 00 mail in its list, and John 00 have only John Smith. Maybe the depth search is alright, but where we are populating. Mm, mm, mm. First account, you're getting first name, and first name as a key, first mail as a key, and then John Smith. John Smith has John New York from here, and John New York and John 00. Yeah. John 00 only has John Smith, John 00, John Smith. John New York only has John Smith. John New York, John New York only has John Smith. John Bravo, Johnny Bravo. Here, which count? Dot get mail. If not visited, if this means it's not been visited before, then add this name to the detail. Go and find all its related nodes, neighboring all the related mails, all the mails belonging to this person, and detail. Yeah, just is there any difference if I do this? Nah. John. Okay, let's check the order. Let's check the mail. System print and then mail. John Smith. Okay. Then this outer loop will run 3 times. String account. What, 40 minutes? It's just okay, 5 more minutes. Second floor. If visitor dot contains this mail already, then return. All right. I think, yeah. We're done. Just need to sort this array. Elections dot sort detail. I hope this is how we sort this. So collections dot sort. How to use this? Collections dot sort. Collections dot sort Java. Utility function list. Collections or reverse or for sorting. Okay, so date and we also have to specify the indexes, leaving the person out. We want to sort from I don't know, first index to the size. How do we specify that? Detail dot size -1. Is that how? Is this how it goes? Well, let's ask lead. Sublist. Okay, thank you, lead. Sub list from 1 to detail size -1. Hmm? John, John, John New York, John Smith. Oh, John New York, John Smith. Wait, 100. But what the second is? Ethan, Gabe. Okay, we also have to. Names should be sorted too. Uh, Zero? No, 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 no. Ethan, Gabe, 0, 3, 1. Okay. I mean, I basically solved the problem. Um, you know, this test case tells us that names are not getting sorted properly. This test case is telling us that emails are not getting sorted properly. So something is wrong with our code. Let's just check. Hmm. -1. That's good. That will solve our problem. is there. Thank God. I don't like doing long questions. There are so many lines of code. But yeah, talking about time complexity. Um, well, the sorting is log n, and we are doing, and the sorting is happening inside the array. Oh God. The sorting is happening inside a loop. So it's a time complexity log and sorting. Because it's happening inside the loop. Okay, and log n, and we are also building this adjacency list that also takes well, it takes what, even it uh, even though it's nested loops here, this is also linear in my opinion, because we are iterating over the same list, and this is a constant here. Yeah, so this is happening in n time, k time, kn whatever, and sorting is log n. Let's just confirm. N k log n k. I don't know what k value is, or n k or space complexity n k. Lead. Tell us. Lead. For each email across all accounts, we add edges. This is totally each email is visited once, each edge is processed once. So that's E. Dominant factor. So n log n, where n is total emails across all accounts. I'm not gonna read all this. I don't care. So yeah, this is it. This is the video. Thank you so much for watching. Bye bye.